Hi, ladies and gentlemen. This is Mr. Green again, and I am here with this pre-calculus recording. We're getting into some topics in Unit 3 that are going to be a little bit, we're dealing with polynomials, and polynomials get to be a little bit funny at times. So, one of the things that comes up in this first study is called synthetic substitution. And all it amounts to is if you want to evaluate a function that is a polynomial, just like this one over here. Step one, make certain you get all the terms. If you don't have all the terms, put 0 in front of the term that's missing. For example, here I've got 3x squared minus 7. I'm missing the x term. So I put 0x in there. I can add that on. It doesn't affect the value any at all. But then I put those terms in order, and I write down the coefficients. 3, 0, negative 7. I'm going to write down the term out here that I'm trying to evaluate with. Then I'm going to put 0 here, and I'm going to add this column. 3 plus 0 gives me a 3. The next step, really, really very easy. All I'm going to do is I'm going to take this 3 times this minus 9, and I'm going to put the value right there. Okay? So 3 times minus 9, negative 27. I added down. 0 plus negative 27 gives me negative 27. I'm going to now take this minus 9 times this minus 27, and it's going to go right here. So negative 27 gave me negative 27 times 9 gives me a 243. I add the minus 7 onto it, adding down like this, and I get 236. And lo and behold, the function, if I evaluate it at negative 9, is going to be 236. The first time I saw this when I was in high school, it just blew my mind. I'm going, you mean it's that simple to do these things? Yep, that simple. You can do this type of synthetic substitution at any level of any type of polynomial. I know the examples, they're contrived, and when you sit down and do them, it's easy enough just to key the number into the calculator and solve it and get that answer. But imagine the hardest polynomial you can think about, the hardest one out there, and this still works. You know what? I want to be totally honest with you. After I saw this working, I was blown away with it. I then got into a computer programming environment, and we had to program how to make functions work. And all I needed to know was that the coefficients all the way down the line. If they gave me the coefficients of all the terms and the value they wanted to evaluate it for, I could use synthetic substitution and make it work. This turned out to be a very simple way of computer programming, how to evaluate functions. And I have used this many times in computer programming. It's one of those types of things that if you know how to do it, it really will make your life much nicer. Now, the other thing that's in this study, it talks about graphing polynomials. And with a graphing calculator, it's really not a problem. You key the polynomial in and it graphs it, right? But there's a lot of times when you're looking at polynomials and you just want to know what it's going to do, okay? And if you know three things, ABCs, if you know those three things, you can basically know what the polynomial is going to do. If you look at the degree, the highest degree that you're going to have, it's going to tell you what the end behavior is going to be. It's on the ends. Whether it's going to do the same thing on both ends or whether it's going to do opposite things on both ends. That means it's either both going to point up, both going to point down, same thing, or it's going to do opposite things. One points up, the other points down. Okay? The leading coefficient tells you on the right side whether it's going to point up or point down. If it's a positive number in the leading coefficient, it means it's pointing up. If it's a negative number, it means it's pointing down. The degree tells you how many turns it makes. So basically, you can look at any type of polynomial once given to you, and you can determine that right side and in behavior. Let's say you're given one and you look at it and you go, well, I can see how many turns it makes, and it does this. I can look at this one right now. Well, there's one turn, two turns, three turns, four turns. That means it was something to the fifth degree, x to the fifth degree. Didn't even have to think about it too much. The fact that it's pointing up here and pointing down here tells me that this a value is some positive number. Why do I know it's positive? Because it's pointing up on the right. Okay? So I use this degrees to tell me how many turns it made. I use the leading coefficient to tell me what it's going to do. This in behavior one, well, they're opposite each other. I knew it had to be an odd number. Okay? This gives me a big clue as to what type of a polynomial I'm looking at. You can do that many different ways, depending upon whether you're given a graph, okay, with a function in it like this. Well, count the turns. 1, 2, 3, 4. Well, it looks like there's one there. 5, 6, 7. Guess what? It has to be something that's x to the 8th term. Why do I know it has to be that? Because my ends are both pointing up. Had to be an even number, right? So I knew that my polynomial had to have an even number in it. X to the 8th. Has to be a positive number here in front, right? Has to be positive. Why do I know it has to be a positive number? Because they're both pointing up. If they were pointing down, it would be a negative number. Now, where do I use this? When I'm looking at multiple choice tests, a lot of times I can eliminate one or more of these based upon those end behaviors, based upon just what I'm looking at, without having to do any type of keying it into a calculator, without having to do anything else with it. Okay? But it's easy enough to use the calculator to get to look at what the graphs are going to look like. I hope this gets you through that first checkup and quiz. We'll be talking about dividing polynomials and doing a few more things, especially with the synthetic math. That synthetic substitution, we're going to take that a step further in the next lesson. So I'll look to talk to you then. Bye.